Okay, so I'm back. I got confused just now, but now I actually get the answer, the question. Okay, example one. You read example one first. Now, the maximum load carried that can be carried by the boat is equal to to the maximum load when your it's the line L here. If it's okay, let me just say it again. So you want to find the maximum load that can be carried by the boat. The maximum load, the maximum weight is reached when the water level reaches the line L. So so the line L, the volume below it is 2.8 meter cube. So you want to find the maximum. So you want to find the maximum amount of weight. The maximum amount of weight that the boat can carry, so that it will still be in equilibrium. Because if you add too much, then it will sink, right? So you want to add just enough. No, it won't sink. It will go over the level that you want. You want to go below. You want to stay below the level of 2.8 meter cube. You want to make sure that it's below there. So so the maximum weight is the weight that you can add on the boat. So until the point where the displacement of water reaches the white line. Okay, if you don't understand yet, I'll explain it through calculation. So remember that it's in equilibrium, so buoyant force is equal to weight of the whole thing, weight of the boat. But remember, we're talking about the total weight, not just the weight of the boat. We want to find the maximum weight possible to reach that 2.8 meter line. So we have to add an extra weight. So we just call it B for now. So yeah, we call it we call the extra weight that you want to carry the B. So we want to try and find B where we want to try and find B. So we know that the buoyant force is equal to W plus B because it's in equilibrium, and we know that W is equal to rho Vg. It's not PVG, it's rho Vg. I wrote it as P because that's how I mean it's nature but it's supposed to be rho Vg. So so rho Vg is equal to W plus B, and then W is equal to mg kan. So yeah. So you want to find the maximum weight. That means you want it to reach the white line. If you want the water to be immersed up to the white line, then the total volume under the white line is 2.8 meter cube. So your M is equal to 2.8 meter cube. So you put it in. You put it in 2.8 meter cube. You put that in 2.8 meter cube. So rho Vg, and then this is the weight. It's the force you want to find. So B is equal to the buoyant force minus the weight of the ship without the weight, without the extra weight on. So in the end, you can carry an extra volume of 21,000, an extra force of 21,000 582 newtons worth of weight. So what if I don't have the buoyant force? What if I don't not the buoyant force? What if I don't have the extra weight? What if it's only the weight of the boat? What if it's only the weight of the boat? Then your volume will be lower because less volume is since the number of the number of the weight cannot be decreased. The gravitational acceleration can also not be decreased, and the density cannot be decreased either. So you can only decrease the volume. So the lower the weight, the lower the volume needed. So so you want to find the maximum. Since you want to find the maximum weight, you want to try and get it into the maximum volume, which is the white line, 2.8 meter cube. So I hope that's understandable. Next part is the raft floating in the sea. What is the width of the raft? That one's easy. W equals to mg. B. Compare the width of the raft with the width of seawater displaced. Remember, this thing is the raft is in equilibrium. That means the buoyant force is equal to the width of the raft. But then also, according to Archimedes' principle, the buoyant force is equal to the weight of water displaced. Remember, the buoyant force equal to the weight of raft is only when it's in equilibrium. However, if the buoyant force, however, in Archimedes' principle, the buoyant force is equal to the weight of water displaced, or the apparent loss in weight, apparent loss of weight. So yeah, you have two answers for this. No, not two answers. Yeah, these two are equal to each other, but since they're asking for weight of seawater displaced, you only want that. So buoyant force is equal to weight of raft because it's in equilibrium, and buoyant force is equal to the weight of water displaced because it's Archimedes' principle. So since they're both buoyant force, they're both equal to buoyant force, so they're both equal to each other. Okay, now I'm gonna go on the hot air balloon stuff. Okay, this is gonna be a bit hard to explain. Okay, so normally you do the thing is right. You know how the ship, my bad. You know how the ship is partially immersed in air. Actually, the air is also considered a fluid. Any gas is considered a fluid, if I remember correctly. Let me just find the thing where it mentions so. Does it even mention it? I know my teacher mentioned it, so that's why I know that it's yeah, here. Fluids consist of liquids and gases, usually applied to liquids because liquids have a higher density. That means gases density are usually quite low. Since they're quite low, you don't really care much about the buoyant force of the thing if it's already in water. But then, for a hot air balloon, the whole thing is in air. So the thing is going upwards. So that means the buoyant force is getting affected. Is affecting the fluid. I mean, like, if you get what I mean is, in a hot air balloon, the whole thing is in air. So that means the whole thing is inside the fluid called air. So the whole thing is being pulled down by weight, and there is also air molecules going outwards. Remember when I talk about the buoyant force is because the water molecules go upwards. Here, the air molecules also go upwards. So this is also buoyant force. So now, I don't know if there's any calculation about this thing. I don't know if there's any calculation about it. But the main thing I want you to know is number one, if FB is equal to W, then this air balloon will be suspended in air. The hot air balloon will be suspended in air. If FB is more than W, that means the hot air balloon will go upwards. If FB is less than W, then the hot air balloon will go back to the ground. Okay, next of all, they might mention, how do you want to make the hot air balloon go down? Or how do you want to make the hot air balloon go up? So if you know how the hot air balloon works, alright, they have these bags here, these sandbags. These sandbags increase the weight of the thing. So you know how the thing is rho g v and then mg, right? So these sandbags, it increases the mass of the thing. So the higher the mass, the higher the weight, the bigger the weight. So that makes sure that that makes sure that the thing stays on the ground. And then if you want to lift the hot air balloon off the ground, you put out the sandbags. So you remove the sandbags, so the weight becomes lesser. The weight becomes lesser to the point it becomes this. Not that one. It becomes this, where the buoyant force is bigger than the weight of the balloon. So it will go up. Then you might be asking, but if I want to keep going up, I'll end up in space and I will die. So how do you stop the hot air balloon? You stop the hot air balloon by opening this thing here. when you open this thing, you let cold air in and you also let the hot air out. So the way I think of it, right, is if you were to make hot things colder, the density will actually, wait, yeah. Wait, I'll explain about the volume first. When if you want to bring yourself back down, you want to open the thing slightly, and then air will come out. So that causes the volume of the gas to decrease. When the volume of the gas decreases, then the buoyant force also decreases. So it will. So you want to try and release it up to the point where it becomes like this again, and then the hot air balloon will go back to the ground. And then I think the last one, let me just see again. I also want to double check. Does density increase with temperature? Okay, yeah. Okay, so it does. Okay, it does. So why is this important? Because okay, wait, actually wait. Never mind. I got it wrong. Okay. Remember this rho, this density gun is the density of the air. Like how when we talk about the density of water, the water punya rho GH, rho GV, or rho VG, the density is actually the density of the water, not the object, the water. Okay, the water. So it's the fluid punya density. So in this case, we are talking about the air's density. So this is the density of air. This is the volume of volume of hot air, which is the air inside the hot air balloon. This is the mass of, this is the weight of hot air balloon. So yeah, I don't know if they ask you to do calculation, but if they do, they will give you the density of hot air. They will give you the mass of the hot air balloon, and then they'll also give you and then they might ask you to find the volume of the hot air. So that should be very easy. You just sub in all the values and you'll get the answer. You just have to know which one to sub it in. And also the thing you have to make sure also is, oh my god, I'm hiccuping. Excuse me. Okay, so yeah, the two factors that affect whether the hot air balloon floats or stays in equilibrium or it floats or it sinks back down is number one, the weight, which is affected by the sandbags. Number two, the volume of hot air inside the balloon. Because if the volume of hot air inside the balloon decreases, if the volume of the hot air inside the balloon decreases, then the buoyant force also decreases. Yeah, then the buoyant force also decreases. So yeah. So the last thing you have to be careful of is, like you know how sometimes can. Okay, if you're not finding you need to be careful with your units. You need to be careful with your units. So usually it doesn't matter if it's cm cube or m cube, unless one situation. If you're trying to find pressure, right? Remember, let me just search the SI unit for pressure. So pressure, Pascal, 1 Pascal is equal to 1 Newton per meter square. Okay, so normally, if you want to find Pascal, you want to try and convert everything to meter. Yeah, you want to try and convert all of the cm to m if you're trying to find Pascal. But but in some cases, like for example here, you only trying to find the force, right? You're gonna find the force only of the in this question. So you don't have to convert the cm into meter cube. You just leave it that way because you only want to find the Newton. You only want to find the n and the cm. But if you want to find Pascal, you have to convert everything into the proper SI units to get the actual value. So you can see in this case, they give you everything in meters, 1000 kg per meter cube, meter square, meter per second square. So they're all in meter already. So you don't have to. So this one you don't have to do anything. But if they if they ask you to find the pressure in Pascal, if they ask you to find the pressure in Pascal, then you need to consider that. But then right, I've been thinking about it, right. I've been thinking about the question. So what if this is cm, and what if this is also cm cube and per cm cube? I will not try and gamble on that, because I will not put my I do not think that will come out in exam. I think when they give out the density, it will be in kg ms minus 3. So you don't have to worry about finding the pressure in Pascal, because they'll give you they'll give you the density in meter already. At least I trust the teacher to do so lah. If not, then you have to do a lot of conversions, and yeah, conversions, not a big fan of him. But just in case they do kan, I think it's divide both by 1000, if I remember correctly. Divide by 1000. So this one, if meter to cm cube is times 1000. Yeah, better for me not to mention this. So yeah, when you're trying to find pressure, make sure that the units are all meter and kilogram. But if you want to try and find like other units, like in Newton for example, force, then you don't actually have to change, because you're only finding the force, not the pressure, unless they give you one in cm and the other one in cm, and then the other one is in m. If they give you one in cm and the other in m, you must make them the same. And I'm not going to gamble my guts, so I'm going to make them both m. But yeah, if they're both cm, like for example in this question where they have the where they have this a2 over a1 thing, right, then you can, because these two will cross each other out anyway, if you get what I mean. If you know maths well enough, you will know this two will disappear, and it will disappear on itself by itself. So you don't have to worry about changing it to meter, then you find Newton. You just, because the centimeter will disappear by itself. So in the final answer will only be in Newton. So yeah, I hope that's understandable. Yeah, I think that's all. Okay, I'll just mention this last part. Calculate the volume of water displaced by the raft. Did I mention this? I don't think I did. So W is the width of the raft. Rho is the density of the water. Density of the water. They will give it in exam. And then you want to find the volume. And then you know that gravitational acceleration is always 9.81. Then you find V of